Let's review Clean Architecture, Part 4, Component Principles by Robert Markin, aka Uncle Bob Martin. In the intro to Component Principles, he says, if solid principles tell us how to arrange bricks into walls, then component principles tell us how to arrange the rooms into buildings. So this metaphor is telling us that we want different architectural principles at different levels of abstraction. And this is a problem. This is not actually true, and this is contradicted by his own chapter 1. He has the principle of equality between low level and high level details. So chapter 1 for the win, the idea that solids should alter at different level of abstraction is an L. We want principles of science. Earlier in the book, we've been talking about a scientific mental model as opposed to a proof-based mental model. Science works at low and high abstraction. Solid can apply at low and high abstraction all the way through. We want consistent principles at low and high abstraction. That being said, let's go into the actual details of what he talks about. He starts out with some history, a history of components that's not really valuable. Principle of relocatability is cool, but it's included in the Liskov substitution principle, which is already in the solid principles. So we don't need an additional principle. It's just a use case. If you can swap out interfaces, then you can relocate code as well. Okay, so nothing really in chapter 12. In chapter 13, we talk about component cohesion. This one's interesting. So he suggests that there's 3 principles of component cohesion. And I think these, first of all, one of them is very good. The CCP is very good. And the REP is also very good, but it's a release principle. It's not a component principle. The CRP is also good, but it's not a component principle. It's a code organization principle that's automatable and solved by tree shaking. He doesn't talk about tree shaking at all in the book. So really, for me, component cohesion boils down to CCP, and this is a really good principle. He does talk about classes a lot. He's assuming OOP, but for the most part, you can swap in the concept of modules or non-class APIs, and the principles work pretty well. REP, really fantastic principle. It says that like people who want to reuse software cannot and will not do so unless those components are tracked through a release process. So if you're releasing a library, people are not going to use your library if you don't have like version numbers and you can't like tell them what changed between versions. They'll just avoid your library. That's super true. Now he talks about release numbers. Those are going to be super helpful. He doesn't talk about SymVar or release numbering strategy. I recommend SymVar. That's going to be great. However, you don't need that. You can get away with a SHA and Git. And there's another consideration here, which is that components are not releasable entities. These are different concerns, okay? And so that's another mistake that I see here. You're gonna need a release number for a releasable entity, but your system might have subcomponents that are not independently released. And that's gonna be the general problem with his REP. So later he will create a tension diagram, but the tension diagram is a false triangle in part because release is a different concern from component organization. So this relation is interesting, but it's not bidirectional and it's ultimately a different concern. So it's true that classes and modules that are grouped together should be releasable together. That's true. But this is not the only criteria for co-releasing or co-building. You also might want to have co-testing so that none of my different components are released until they pass a unified build process. Okay, so that would be like a monorepo. He doesn't talk about monorepo at all here. So it's a good principle, but it's not a bidirectional principle, and it's a principle of release organization, not a component principle. Again, I might have multiple components that are released together in a monorepo, and I do that because I want them all to pass to each other's test suites, is one example illustrating why the release concern is different from the component concern. This common closure principle is an actual component organization principle, and I really, really like this one. And it's not that complicated. We want to define a component as that API which changes for the same reason and at the same times, okay? So he said classes, I said that API because you could have a non-class module or an API or whatever. But still, when you have interrelated pieces, interrelated units that are changing for the same reasons or the same times, that should be a common component. That could be a library or a component or a subsystem. And that's a matter of code organization regardless of release. Even inside of a system that has many modules, you might have one system with many modules, and you might release that system at one at a time, but you might not release those modules one at a time, okay? So it's different from release concern. You still want your code modules to be organized according to this common closure principle. So here, what are we calling a component? It's just a collection of units. It doesn't need to refer to like a Lambda or an EC2, right? We're not talking about physical components like that. We're talking about a a collection of units, basically. And those units may or may not be released together. And those components may or may not be released together. And there's some similarity with SRP here, right? So basically, CCP is SRP extended into module organization. He talks about the common reuse principle, and he basically says, don't force users of a component to depend on things they don't need. That's true, but that's not a need to like reorganize your modules. This can be solved with tree shaking. So there's a technical solution to this. Tree shaking in particular, you can go Google on that, but explicit functional stateless patterns will facilitate tree shaking. He doesn't talk about any of these, and I'm really bummed because these are like real architectural principles, right? So it's a good idea, it's a good principle, but it's invariant, it's unrelated to the component boundary. And he's also missing some concepts here, right? In addition to those concepts, he's also missing the idea of intelligent defaults that are easily customized like a Webpack architecture. So he basically indicates that you want to have your releasable components is minimum set of interrelated code, like an irreducibly complex collection of units should be releasable. That is a poor mental model. You want to have intelligent defaults. You want to target the usual consumption case, not the minimal consumption case. So you should have an intelligent default. And then if there are some abnormal users that want a subset, they should be able to tree shake and customize. But you don't want to tailor to those minority use cases out of the box. You want to target the general or recommended use case out of the box. So don't depend on things you don't need. Good idea, but it's solvable by tooling. And now we get to this tension diagram. So he's going to say that there are these three principles and they're at tension with one another, and you basically use empirical data to find your location here. I'm going to say this is solved by tooling. This is a release concern. So the solution to the triangle is to decouple the triangle. And the true organization is just the CCP. This is the true organization for your code into components. This is going to be the single rule that you need, and that you can decouple that from your release process. Not only you can, but you should decouple that from your release process. So you want different abstractions here. Like I'm going to have maybe a Jenkins or a Circle CI or a GitHub action over here. I'm not going to be doing, Python modules and then a Python code for my release process. They're different concerns, different tools. Keep it separated is the solution to this triangle. Chapter 14, he talks about component coupling. This is the resurgence of non-economic thinking, I'm going to argue. I didn't really like this chapter. So he says that there's acyclic dependencies and that you can apply like this principle to break it into a DAG. That's one option. Another option is that an irreducibly complex collection of units is a component, and that also harmonizes with the CCP. So you basically can ignore this. Like, you don't need to do that. Weekly builds, yeah, they're bad. We should be doing continuous delivery, like we know this. Cool diagram. So he's going to say that to break a cycle, you want to apply DIP. This is not the case. You can break a cycle without DIP. And one solution I talked about is just treating the whole collection as a component. And then on the next page, he's going to say that you can't do top-down design. Well, DIP is top-down design. So I think it's easy to resolve this paradox. You just ignore DIP. Prefer the principle of co-equality that he talks about in chapter 1. He's going to say SRP and CCP are super important, and I'm going to agree. Remember, CCP is the one good rule of component organization, in my opinion. I'm going to say SRP and CCP are important regardless of DI. They're not in tension with DI. You can just ignore DI. He has this stable dependencies principle. I think this is mistaken. Stability is a second order concern, stability of the code. Now, when he says stability, he's not talking about like flaky tests or something like that, which would be a big problem. He's talking about the speed and frequency of change, the code under change. So he's going to say you should depend on those modules which change less frequently. I'm going to say no, that's not the case. You want to depend in the direction of profit maximization. He doesn't talk about these concerns at all. Designs cannot be completely static. Indeed, they shouldn't be. We love Agile, we love design thinking, we love science, we love iteration, A/B testing, continuous delivery. And he has like a long discussion on stability. It's really simple. Stability means it's difficult to change, okay? So we want those parts of our system to be difficult to change when profit depends on them not changing. We want tests and types. These are going to increase stability and reduce change frequency. They're going to lock in, and we want to lock in benefits. We don't want to lock in garbage. So we want to lock in the profit maximizing modules, right? Not all components should be stable, he says. That's true. We want to enable change when enabling change is profit maximizing. He talks about abstract components. This doesn't matter at all. They aren't needed for stability. I disagree with the stable abstraction principle. I say a component should be easy to change if and only if changing it easily is profit optimal. I think coupling's not that hard. You just generally avoid it. All right, follow for the next section.